Classification of elements. Classification. Classification of elements. Right? Why we do classification basically? Do you have any idea? Classification is done for for better understanding. Better understanding. Better understanding of elements and their properties. And their properties. Right? For better understanding of elements and their properties. And second is it it makes study easy. Right? All the elements of one group have similar properties, so it is better to if we understand the property of group, then we understand the property of matter, and each element is somewhere similar to that, right? So this is the benefit of classification, right? In If we talk about in chemistry especially, just say if we talk about uh, you know first group first group all elements have one electron in valence shell, so electropositive electropositive, right? And they are they are metals, alkali metals, right? First group is called alkali metals, and strong tendency. अबे, ये क्या कर दी? Strong tendency to lose electron, right? So after knowing these property, and they are applicable for all hydrogen, sodium, sorry, lithium, sodium, and potassium. So we have studied, if we know the property of first group, then it means कि we know the property of these also, right? एंड नहीं, वो एक कंट्रोवर्शियल मैटर है, ठीक है, वो एक कंट्रोवर्शियल मैटर है, लेकिन दे ऑल आर हाईली रिएक्टिव, हाईली रिएक्टिव, राइट? So this is we know, this is the benefit of classification. If we know the properties of group, we somewhere we know that we are familiar with the properties of elements, so it make us easy to understand, right? So make the study easy also. So now initially this classification of elements, this thought came to Debonair. Initially this thought came to, yeah, wait for a while. Initially it came to Debonair. Debonair. Right, Debonair. Initially he initially think for classification. For classification. Right, of elements. He make triads. He make triads. Triads. Each triad contain three elements. Three elements arranged in increasing order of increasing order of increasing order of atomic mass, right? And he said, if in a triad, this is the A, B, and C, these are three elements. If atomic mass of A is X and B and C is Y, then atomic mass of B will be X plus Y by 2. This is atomic mass. Atomic mass in increasing order, right? But he was actually, his concept was, who is there? Yeah. Hello. Hmm. So X plus Y by 2. So initially his uh, atomic mass X and Y, increasing order of atomic masses के basis पे था. But at that time very few elements were known, as well as atomic masses. He was able to make only two three triads, right? He made he able to make able to make only 2-3 tries, right? Only after that he was not able to do the things in such a way. So this was the initial thought was there. So we are understanding, but it is totally unlogical, right? It was unlogical. After that after that one actually he was a chemist basically. He was a chemist. Chemist means selling medicines. Selling medicines. So he was not having that much idea of things, but in best of his knowledge and experience, he tried to do the things and he done this like that. But after that, there was concept came by Debonair. Should I rub this? I rub. Okay. Now the concept came by Newland, right? Newland. Newland gave us an idea. Newland, right? Newland. He said at that time, only 56 elements were known to us, known to us in that no noble gases, right? But but he said there are there are only 56 elements in the universe, right? Only 56 elements in the universe, right? So he said only 56 elements in the universe and no other no no possibility of discovery. His thought was like this: no possibility. Sorry, no possibility of discovery. No possibility of discovery of new elements, right? So this was his thought, and he gone, failed here itself. He gone failed here itself. He only 56 elements will be there in the universe, no possibility of discovery of new elements, right? But but he is we are appreciating him that he told us periodicity 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 of properties of elements, right? Periodicity of periodicity of properties of elements means as per his as per his uh, as per his concept, he arranged he arranged he arranged elements elements in increasing increasing order increasing order of atomic masses, right? He arranged elements in increasing order of atomic masses, and and every eighth element every eighth 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 every eighth element element repeat property of first, right? So he arranged elements in increasing order of atomic masses, and every eighth element repeat properties, right? So he arranged them in a like this: sa, ha, re, ga, ma, pa, dha, ni, and again sa, right? So this is right. This is first element, and this is the eighth element. So this is in this arrangement he did, but he was wrong with this. So this concept is accepted. But only this concept is accepted that matlab, uh, properties of element. This was accepted, and because of that we are studying it. Otherwise, he was wrong. He said only 56 elements and no possibility of new elements. So he was wrong in that. So now, should I rub this? Done. Pratham, you have done? Ah, very good. Okay. So now, now Mendeleev came in, right? Now Mendeleev came in. Mendeleev, right? Periodic table. Periodic table. तो इसका प्रिंसिपल क्या था? Principle was, it is right, correct? Principle. Principle was of physical, physical and chemical properties, chemical properties, properties of elements, elements are periodic function, periodic, periodic function, periodic function of their atomic masses, right? So Mendeleev periodic table principle was physical and chemical properties of element are periodic function of their atomic masses. Is it? In his periodic table, there was there was seven horizontal horizontal columns called periods, right? And there was no horizontal, eight vertical rows, eight vertical rows, right? Eight vertical rows, out of which eighth one, eighth, eighth for noble gases, noble gases, and seven groups were further divided further divided into A and B subgroups. A and B subgroups. right? Manley's periodic table, physical and chemical properties of elements are periodic function of atomic masses. There was 7 horizontal columns called periods and 8 vertical rows, 8 for noble gases, and 7 groups were further divided into A and B subgroups. Right? He left. He left spaces for unknown elements. Unknown elements with named, named with prefix eka. Right? Eka silicon, eka germanium, like that. He left spaces. So initially, when eka silicon, eka germanium, so when boron was discovered, right? So we come to know that their properties were were same as Mendeleev was predicted. For smaller elements, for lower elements, his prediction was for lower elements, for lower elements, for lower elements, his prediction, his prediction of properties properties was correct. Right? So he get appreciated. He get appreciation. Right? Since his prediction for lower elements was correct. Right? Have you written this much? Okay, okay, do it. And what about you, my son? Done? Okay. So what were the controversies with him? Lower elements के लिए he was okay, right? So what was the difficulties with him? Why we not continued with Mendeleev? So this was a matter of debate, right? Should I rub this? Okay, I did that. I did that. So drawback of Manley's periodic table. Drawback of Manley's periodic table. Right? What were those? First, not able, not able to arrange isotopes. Isotopes. Right? As isotopes, isotopes has isotopes has same atomic number, same same atomic number, atomic number, but different mass number. Mass number. Right? What I wrote as same same atomic number but different mass number. Like hydrogen has one H1, one H2, one H3. They all are having same atomic number but different mass number. Right? If we talk about carbon, so there is carbon C612, C613, C614. Right? These are the isotopes. So when periodic table is on the basis of mass number, so how you will arrange them? They need a different place since their mass number is different. So how you arrange them? So he was not able to do that. Right? Further, 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 for upper elements, upper elements, upper elements property, properties, for upper elements properties were having variations, variations, not able to explain lanthanide, lanthanide and actinide series well, series well, right? And the last one was not able to arrange isotopes for upper elements properties were having variations, not able to explain lanthanide and actinide series well, and series position, not able to explain lanthanide and actinide series position well. Position well, right? And lastly, like nickel and cobalt, right? Atomic number of nickel atomic number of nickel was less, and atomic number of cobalt was more, but but cobalt written written first, then nickel, right? मतलब एटॉमिक मास जो था वो निकेल का कम था कोबाल्ट से. They were increasing order of atomic masses, na. Periodic table was in the increasing order of atomic masses. So when nickel is having less atomic mass, so it should be placed first, and after that there must be cobalt. But there was cobalt written first, then nickel. So ये जो इन्होंने interchange किया, why he did, he was not able to tell us. So but with all these drawbacks, right, his people start thinking some other thing also. They find it is pretty good for lower elements, but for in terms of isotopes, in terms of properties discovered of upper elements and positioning of elements of lanthanide and actinide series, and this kind of anomalies like nickel and cobalt were with other elements were also pair of elements were also found. So he was not able to explain that. So people start thinking some other ways to arrange elements in a table, right? I hope you understand. Okay. Now, now came in existence modern periodic table. Modern modern periodic table, right? It was proposed by it was proposed by Henry Moseley and his associates and his associates, right? It was proposed by Henry Moseley and his associates, and he made a drastic change in the thought process in the principle of periodic table. So principle of principle of periodic table periodic table based on periodic table principle of periodic table was physical physical and chemical properties properties of elements. Physical and chemical properties of elements are periodic function periodic function of their atomic masses. Atomic masses. Right? Sorry. Atomic numbers. Atomic numbers. Right? Atomic numbers. So this was the drastic change which they made in the arranging elements. Now they arrange the elements on the basis of their atomic number. Right? Atomic numbers. When when arranged when arranged when arranged on the basis of atomic numbers atomic numbers when arranged on the basis of atomic numbers, problem of isotopes problem of position of isotopes removed. As element isotopes of an element isotopes of element have same atomic number. So all get one position in periodic table. I hope you understand. Matlab, when they changed the principle of periodic table and said physical and chemical properties of elements are periodic function of their atomic numbers, then problem of isotopes get removed immediately. because all the isotopes have same atomic number, and when they are arranged on the basis of atomic number, all the the isotopes of an element get one position in the periodic table, right? So this was the this is proposed. This is modern periodic table, and electronic configuration also help us to understand the things. Electronic configuration, right? Electronic configuration, electronic configuration help us to understand in more better way, right? Wait, more, wait for a while. Better way, right? I hope you understand. Hello, all of you are with me. You have done this much? Doing. You can take the screenshot. It's having theory part, so right. Should I rub this now? Okay. In modern periodic table, there was there was 7 horizontal horizontal columns, 7 horizontal columns, which we call we call period, right? And 18 vertical rows. Vertical rows. 18th 18th row belongs to noble gases, right? First and 17th row belongs to halogens. First row belongs to alkali metals. Second row belongs to alkaline alkaline earth metal, right? Earth metals. And there was seven there was seven periods, seven periods, right? Seven periods. First has two elements. Second and third have eight elements each. Eight elements each. And fourth and fifth period, fourth and fifth period have, I hope, how many? 16 each. Huh? 16, 16, 32, 32 and 16. This is how much? 48, 48, 48 and 2, 50, 50 and 64. Sorry. Yes. It should be 18. So, yeah. 13, fourth and fifth period have 18 elements each. 18 elements each. And and sixth and seventh period have 32 elements each. 32 elements each. So therefore, there are, if you calculate this, you will get 118 elements. 118 elements. Getting? If you count this, you will get, there is 2 and there is 8, 8, 16 that I was doing. You know, there is 2, 8, 8, 16. Then this is 36. And then 32, 32 is 64. Right? How much you get? This is 6, 6, 12. 12 to 14 or 4, 18. You get one carry. And this is 11. Right? So therefore, 118 elements known to us. Get it? Done? Okay. Should I rub this? Okay. So, this is group and this is period, right? If I make arrangement like this is, right? So this is, so there is group 1 alkali metals, group 2 alkaline earth metals. After that, squeeze, and then we reached group 13, then we come to 14, 15, group 15, 16, 17, and this is 18th group, right? Okay. Now, this is period 1, this is period 2, this is period 3, right? And this is period 4. Remaining now, after that there is so much complication, so we will discuss it later, right? And this is squeezed portion. There are 18 elements, so there are also d block elements there, right? Like that. So, if we take period 1, second, third, and fourth, right? And in first period, we have, hydrogen with atomic number 1, and we have helium, inert gas. Fine? Hello? All of you getting me now? What I'm doing? Okay. Then we have lithium, beryllium, boron, nitrogen. No. Boron. Then we have carbon. Then we have nitrogen, oxygen, fluorine, and neon. Right? I hope you understand. Hydrogen का electronic configuration is 1. Its configuration is 2. Lithium configuration is 1. Sorry. Atomic number is its configuration is 2,1. It's 2,2. It's 2,3. It's 2,4. Nitrogen is having 2,5. Oxygen is having 2,6. Fluorine is having 2,7. And neon is having 2,8. Right? And their atomic numbers are, as we know, 3, 4, 5, 6, 7, 8, 9 and 10. Right. After that we come to sodium. Sodium 11, magnesium 12, aluminium that is 13, then silicon having 14, then we have silicon, then phosphorus 15, then sulfur 16, then chlorine 17, and then we have argon that is 18, and then we have potassium. Potassium is 19 and calcium 20. Right? This is now their electronic configuration is here it is 281, it is 282, it is 283, it is 284, it is 285, 286, 287 and 288. Right. After that we have 2881 and we have 2882. Right. Beyond that, principle is change. Right. These are the lower elements, so they work on this principle. But after that, we have different philosophy. So that's why I skipped these groups also, and the elements after that you will discuss it your higher classes, right? Abhi, what you are looking here, what you are finding? Can you tell me when I write down all the atomic numbers, all the configurations? So what you are getting in that? What is your analysis? Can you tell me? Huh? Huh? Yeah. So the first thing is that the electronic configuration is telling us help us to find out the position of element in a periodic table. It is having how many shells? One. And what is its how many valence electrons? One. First group. That's why it is getting position first group and first for the first period and first group, right? Because one electron in one shell, and it is having in first shell there is two electrons. Maximum two electrons can have first shell, so that is helium. Nobel gases, right? And you see, no doubt, hydrogen. They are known as alkali metals. But hydrogen is a gas, highly reactive gas. Reactivity is very high, no doubt at all. But it is a gas. But and it yeah, it is non-metal also. And one property it is having, it is highly reactive, right? And it is and but problem is that it is having one electron in its outermost shell, and it can have two electrons maximum. So it is having only one electron less. So it is having both property to lose electron and get the positive charge and behave like a metals, and take one electron and behave like it is having both property. Hydrogen can lose one electron and get positive charge and become electropositive, and hydrogen take one electron and get the electronic configuration of helium and become electronegative, right? But problem is that since our periodic table is based on atomic number and hydrogen is having atomic number 1, so we have given its position 1 in the periodic table, right? As you are seeing, number of electrons are increasing. Number of electrons are increasing in valence shell, right? Number of electrons are increasing in valence shell. So what happens? These are metal. Then they are metalloids, and these are non-metals. So you can see that the metals, when elements are moving from left to right in a period, their metallic property is decreasing. When you are moving left to right in a period, then their metallic property is decreasing, and their electro their electropositivity is decreasing and their electronegativity is increasing. But the property of losing electron is decreasing and property of gaining electron is increasing when we are moving from left to right in a period. Similarly here also, in this period. Similarly here, right? So what happens? So this is what we get. And when there is a one electron in lithium in outermost shell. There are two shells, so it is close to the nucleus, right? So electrostatic force of attraction between positive and negative. So it will be it's larger. When But in beryllium, there are two electrons. Now, four electrons in outermost shell and four electrons in nucleus, and second orbit is close to the nucleus. So, their electrostatic force of attraction increases. So their atomic radii decreases. Right? When we come to boron, it's more decreases. In carbon, it is more decreases. Nitrogen is keep on decreasing. So atomic radii decreases from left to right because number of electrons are increasing. So, electrostatic force of attraction between electrons in cells and protons in the nucleus is increasing. So their atomic radii is decreasing. Right? But when we are moving in a group from top to bottom, then their atomic radii is increasing because it is having just one shell, it is having two shell, it is having three shell, it is having four shell. So their atomic radii is increasing when we are coming from top to bottom in a group. When we are moving left to right in a period, atomic radii decreases, right? And then left to right in period, right? And when top to bottom, top to bottom, top to bottom, atomic radii, atomic radii increases as number of shells increases, right? can say that electro electropositivity. Oh my God. Electropositivity. Positivity decreases, right? And and electronegativity 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 increases increases, right? So metallic property decreases. So we can say metallic property decreases, right? And non-metallic property increases. Get it? So what I said? What I said? Uh, uh, what it means? Uh, नहीं, they are not in your syllabus. What I have written, that is confirmed, right? So this much we have about periodic table, modern periodic table. Further, some more topics we will discuss later. Okay.